Hey, what's up guys? As I'm Mark Yoon, and today I'm bringing another hopefully exciting video. So what I'm actually going to talk about today is netcode, the importance of netcode in fighting games. This is going to be coming up because yesterday I made a video discussing how we can bring the online community together as well as the offline community, and I heard a lot of talk about netcode and a lot of criticisms and also a lot of I got some misinformation floating around about netcode and its application and its usage and even what netcode is. I no lie had someone actually tell me that with netcode you don't have to connect to servers, which servers is what runs the entire online infrastructure. It's just a computer communicating with another computer. So I wanted to get a little bit into that today and hopefully answer a bunch of questions and clear up a lot of that miscommunication and go from there, I guess. So what I wanted to start with is just saying that, what is a netcode? This may be super simplified for people that already understand the topic, but there's a lot of people that actually don't even understand what a netcode is. So to get us all kind of on the same playing field, I'm going to briefly just surmise what a netcode typically is and what we mean by netcode. So netcode is not actually a very specific thing to it's an action, not a thing. So when we're talking about netcode, it's basically communication between two computers. So if we have your computer being your console, or your computer or your PC communicating with the server of the whatever you're trying to do, and then that communicates back to a player that you're actually playing against. And those three things in tandem working together is what would constitute a netcode. Now, a netcode is actually the functionality underneath of that communication. It's how the computers communicate with each other. I'm sure you've heard a lot of different ones like rollback or delay based or even prescriptive. So there's a lot of different variations on that, and I'll talk a little bit about all of those and pretty much just what netcode is and why it works good for some and not for others. I've heard a lot of people kind of talking about Harada as being lazy because he won't put rollback in Tekken 7 that is, and a lot of things have to do with that because as one of my members, Death is All 777, said in an old video, that it kind of has to be built from the ground up with rollback in mind to help with frame delay, as opposed to just throwing it in there willy-nilly, because it doesn't always work and it's not a band-aid that applies to everything. So let's get into it a little bit and we'll start talking. So as much as fighting game fans wish that creating good netcode was simple, implementing rollback takes work and requires commitment and a strong belief from the studio that high quality online play is a priority. Now obviously when people talk about a lot of these things, they always say, let's just fix the netcode, fix the netcode, and that's what's risen out of that is a few games implementing specifically Arc Systems Works games and MK11, that they have rollback, so the netcode is really good. So automatically a lot of people are going to be saying rollback, rollback, rollback for everything, which doesn't actually completely apply to all of that. So let's talk about how the game must be built for that, right? As a brief reminder of how rollback works, when remote inputs are unknown, the game simulates forward anyway with its predicted inputs. If those predictions are incorrect, when the real input is received, the game must roll back by loading a previous game state and simulating several in-game logic frames. So it's pretty much predictive in nature. It goes based on how you've played before or how most people generally play or the character's movesets, what's good in which scenarios, and how that's often put together. Now, the prediction comes in mind of it does fix itself if you do put a different input in than what it actually is prescribing on screen. It will go back and fix that, which could cause some lag or delay, but it's nowhere near as much as a delay based, for example. So we're gonna keep on going on. The primary requirement of rollback game is that it can save and load different game states and simulate game logic in the background, and it must be able to do all of this very rapidly. There's already a lot to unpack with just this little statement alone, right? So the act of converting objects in a computer memory to format that it can be saved and loaded is called serialization. And the game state for every single frame must be serialized and saved in case we need to roll back to it later. This means that your game state serialization, which can be time-consuming operation depending on the data, must be lightning fast and very well optimized. Depending on how the game has been built, you may even need to change how the data is stored and how various systems in your games use it to gain necessary performance. If you build your game with rollback in mind from the start, it can lessen the burden, but adding rollback to an existing game can mean a lot of system-wide changes to the very core of the game. Michael Stallone, engineer at NetherRealm Studios, estimates that it took him and his team 2 years to build optimized serialization systems in Mortal Kombat X when they retrofitted the game with rollback netcode. If the game needs to roll back a large number of frames, once the previous state has been deserialized and loaded, the game must re-simulate all of these frames back to the present, and then also serialize all of them. And this must be done quickly and in the background. This means the game's logic must be independent from everything else in the gameplay loop. You need to be able to run many frames of logic without rendering it to the screen, or waiting on the network, or use any number of other systems that normally operate every frame. Depending on the engine you choose or how much customization the engine provided game loop systems you've done, separating and turning off these subsystems may be surprisingly hard. Because all these things need to be performed in one game frame, in addition to all of your normal game loop operations, optimization in general is another key concern. Perhaps those costly CPU cycles that your fancy particle system or cloth simulation uses now putting you over your performance budget. Or maybe you've been playing fast and loose with your console's power because the need to be extremely efficient wasn't there when you initially built the game. Stallone from NetherRealm says that MKX, under its old delay-based solution, took an average of 10 microseconds of its 16 ms budget to run a complete frame due to the extra horsepower of the PS4 and Xbox One. When initially switching to a non-optimal, naive rollback solution, he says that the cost to run a frame more than tripled to 32 ms, which forced his team to reevaluate almost every single in-game system and look for performance gains. By the way, guys, this portion of the video I'm reading from an Ars Technica article, so I will link it in the description box down below. Note that deterministic games can use rollback netcode as long as it is able to be saved and load game states and perform multiple frames of logic quickly, enough to fit inside of its game loop. To dispel a common myth about rollback, there are no limitations based on the genre of game. Rollback could be and has been the same used for 2D and 3D games alike, including Street Fighter 3 Third Strike, Online Edition, Killer Instinct, Brawlhalla, and For Honor. It's also used outside of fighting games. Iron Galaxy incorporated rollback netcode into the 4-player action game Dungeons & Dragons Chronicles of Mysteria, and games like Rocket League incorporated rollback to make online play as responsive as offline play. So obviously, I have said in the past too that it's based on frames of animation, so I was completely wrong about that before actually going in and researching this. So a lot of people that will say that well, this is a 3D game so it can't be implemented as easily as something like a 2D sprite-based fighter is actually not true. That's just like a misnomer that's been put out there, and I have reported on that myself, so hopefully this clears up to the people that look to me for information. All netcode solutions, whether driven by input delay or rollbacks, must keep both systems running completely in sync. This means both systems are showing each player the same frame at the same time, or as close to it as possible. Even though most fighting games try to lock the frame rate at 60 frames per second, it's not simply enough to sync at the beginning of a match and assume all players will remain in sync for the entire fight. Many issues outside of networking, such as consoles overheating, computers performing operating system functions, or someone temporarily overloading their CPU, can cause performance drops, which will put out of sync with their opponent. The consequences of not correcting this sync are catastrophic. Consider a rollback system where player A is being shown frame 20, but player B is being shown frame 23. Across a network delay of 3 frames, player B will send their input to frame 23 to player A. Because they are on frame 20, network delay means that they will receive an input of their own frame 23, which is just in time to execute and will not have time to roll back at all. Meanwhile, player A sends their input for frame 20 to player B. With the network delay, player B will receive this input of their own frame 26, which is repeatedly cuts lots of uncomfortable 6 frames of rollback, which is insane. Now that rollback is entirely one-sided, only the player who is ahead of the other player will experience the effects of the bad connection, which is kind of one of the downsides of it, because if you're playing against somebody with a crappy connection, rollback, it's not, like I said, it's not a band-aid fix for all. You also still have to consider bandwidth. You also have to consider how much ping data or how long it takes for data to be transwired over the network from your network to another network. Because if people have really bad internet, the one who has the better internet is usually going to feel the effects of that. And I've witnessed this, and I'm sure most of you have witnessed this from time to time as well when you're playing with somebody with like, you know, one bar, like you're the one that's going to have the effects of the lag. That's why we have that whole modem of saying like, oh, well, you didn't win, your network won. And like if you have a bad network, you can win because it's easy to cheese the system based on the frames. But solving the problem is relatively straightforward. Most rollback systems will briefly pause the player who is ahead for 1 or 2 frames so the player who's behind can catch up. If the game keeps on top of this system and never lets the game drift very far apart, then a correction will be quick and painless. Note that these pauses are not due to missing input or any other network delays. They're just designed to fix the fact that different computers will run software at different rates in unpredictable ways, and losing 1 frame every 10 seconds to maintain the sync is unnoticeable, and even like most players expect it. So what exactly is a Ggpo? If you spend any time around the fighting game community, you have undoubtedly heard the term Ggpo. The rollback library written by Evo co-founder Tony Cannon. You'll often hear Ggpo and rollback used interchangeably among fighting game fans. Ggpo's first release in late 2006 was designed to test the concept of rollback with popular legacy fighting games running on emulators, and shortly after, Cannon released a version of the library that could be licensed and incorporated into modern games. The main function of Ggpo is to provide a robust solution for syncing machines and game states. For example, Ggpo can tell your game when 2 machines are out of sync and by how much. It can also keep track of the inputs of all connected parties and tell your game when to roll back, by how much, and what the new inputs to apply during your rollbacks. Because Ggpo is well tested and proven as a solution to handling these parts of the rollback framework, it is an excellent asset towards making games that want to use and utilize rollback netcode. However, the act of actually performing rollback still falls on the developers. They have to make sure their game is performance-based, their game logic is properly spit away from the parts of their game loop, and all edge cases are handled intelligently. Ggpo simply tells them when and why to roll back, and what the new inputs should be to simulate your game with. It does not concern itself with a particular implementation of how the game achieves these goals, which makes it a flexible tool, but not the complete suite of functionality needed for rollback to actually work. It's also meant that some games, including Killer Instinct, implement rollback netcode without directly using the Ggpo library to coding their own in-house solution and tracking the game state and the syncing of clients. Which, obviously, a lot of that is going to fall on the developer, as we've always said before. There's a lot of things that actually go into dealing with this. I'm trying to speak fast because this is going to be a long video already, and I just want you guys to get the information. We have a lot of things to deal with. We have international play. We have people that are actually trying to play with bad internet connections. So you have it up to your internet bandwidth. You have it up to the person's internet bandwidth you're playing with. You have it up to the servers. You have it up to whether or not they have implemented some kind of Ggpo, and you also have it up to developers making their game states, being able to put all this in the background in the course of 1 frame. So a lot of this stuff is really intensive and complicated, and there's also going to be edge cases. As if rollback wasn't complicated enough, it's worth mentioning the few of the edge cases you'll run into in supporting game loading up in the past. Creating and destroying objects becomes more difficult. Let's pretend a local player throws a fireball and the opponent holds down back in front of the fireball, ready to block it. Rollback uses predicted inputs to play out the opponent blocking this fireball on the local player's screen. The fireball is destroyed when it's blocked and the particle effects around the fireball are shown. But then remote inputs come in and turns the opponent did an invincible move through the fireball right before it's blocked, which means it's actually not destroyed and must continue traveling through the screen. And in many games, recreating the fireball after it's been destroyed is expensive and can lead to odd visual popping. A solution many rollback games take is to simply save objects for many frames after they're destroyed, in case rollback needs to undestroy them, which may require some changes in the game's logic. Particle systems also require a lot of special attention. Audio is also a particularly difficult problem for rollback in games. Sounds that were played in a predicted version have to be cut short and stopped in the rollback version, and perhaps sounds that were never played in the local version may be played several milliseconds in when the rollback changes the game state. This is especially problematic when you remember that game logic needs to be divorced from all other aspects of the game loop. In early versions of rollback in modern games like Street Fighter Cross Tekken, there were horrific sound bugs that would cut out for seconds at a time, or that was played when you simply pop and play out of sync. Tony Cannon gives some advice on how to handle audio and rollback engine in Game Developer Magazine article, specifically separating the game state rendering section. There may also be times where you never want to roll back. like brutalities in Mortal Kombat X or stage transitions in Injustice 2. This just means that they must prevent those events from executing until the local player is 100% positive the event occurred and cannot be rolled back. This leads to extra engineering and debugging efforts across all gameplay system teams, and therefore an extra expense. You also have to correctly copy the last known frame during your prediction algorithms. This includes what directions the remote player was holding, as well as the buttons that they're holding and not holding. And to mess up this prediction, you can cause a remote player to do something it never actually did, which will be incredibly disorienting when it gets rolled back. And I'm sure everyone's had these instances where, like, for example, I was playing Power Rangers Battle for the Grid with a subscriber and a friend, and on his screen it showed that he won the match, and on my screen it showed that I won the match. Which, how does that work? You know, obviously there was some kind of implementation error there, which really, like, bugged me, because, like, it happened for half our matches where, like, we didn't know literally who won because it both showed us that we both won. There's no denying that adding rollback to a game takes effort and expenses, and I don't want to take away from this section to feel like implementing rollback is too difficult to be feasible. The reality is somewhere in the middle between copy and paste Ggpo to the game in an afternoon or invest your entire budget on rollback systems. It largely depends on when you decide to implement the rollback. Adding rollback to a game after its gameplay systems have been built is very challenging. When NetherRealm Studios decided to patch in rollback netcode for Mortal Kombat X, a game that had already shipped, it took approximately 8 man-years of time split between many programmers over 10 months. The very small studio behind Rivals of Aether spent a lot of development over a few years of how to convert their finished game into delay-based rollback, but eventually had to move when it was proving too costly onto the other side of the spectrum. Implementing rollback also gives you some added benefits in other areas of your game. For example, if your game has a robust method of saving and loading game states, you can use it to provide better training mode options for your players. And when you've implemented rollback, you can reap the benefits of knowledge in future games. After putting in the hard work for MKX, NetherRealm and its fans enjoy smooth netplay, and all their future titles were built off modifications to the same engine, including Injustice 2 and Mortal Kombat 11. But in reality, rollback netcode is far from the first worthwhile advancement in technology to make more work from previous method. Animation techniques such as inverse kinetics are now standard in many games. Despite being a higher initial investment, many studios implement effectively, and after years of working on the problem, developers now have the tools to improve it even further. But the value of rollback is definitely there, and developers should not be wary of prioritizing the benefit to their game. After all, if there's anything more important to a modern fighter than smooth, reliable, consistent online play that can connect communities online. It's literally the entire purpose. There are other, variations on this, like I said, predictive before, and they all work similarly, but to different means and to different effects. So, like, rollback is literally just you sending the signal to the game interpreting that signal and making predictions based on that systems, and then going through those systems, but having to check in the course of one frame, then rolling back so that the frame actually can go through. It's a lot of work, it's a lot of money, it takes a lot of enhancements, and like DeathZol777 said, you have to literally build your games from the ground up in order to implement it properly, or else it's going to be way too costly and time consuming for games to be able to implement. So when people are saying, like, oh, Soul Calibur 6 needs rollback. Well, Soul Calibur 6 was a budget game that was built by a small studio, which is a subsidiary of Bandai Namco Studios, much smaller than Tekken's team, and there's no way in hell that they would have the budget to be able to implement a Ggpo type system in post-game. Like, we'd be half to looking for something being built right now for probably Unreal 5 for Soul Calibur 7. And this goes for any other game that you play that doesn't have rollback. But there's hope, and we can have a better online play soon, but we need to work on not only developers implementing the system from the ground up, but we also have to work on the technology getting better, and we have to work on internet connections, because at the end of the day, anything is going to be as connectable as one person's bandwidth against another person's bandwidth to the servers. I know a lot of people use keywords when we're talking about these, but they're all the keywords are actually used in all of these. Like prediction based, that's part of rollback. Rolling back, that's part of rollback. All the Ggpo functionalities of making predictions. Frame delay is another one. A lot of people like to say frame delay based, but frame delay based is still can be considered part of rollback. It's just a descriptor. It's not actually a defining trait of it. So I want to cut this video to a close now because it's already been going on for 20 minutes. But let me know in the comment section down below if you felt this video helpful, and if you have any more information you'd like to share with people down below. If you are going to make a statement like that, though, please leave resources like a link so that people can follow it. And I'm not going to curate those, so it's up to you guys to follow those with your own intentions, pure and with the grain of salt. But I'm going to bring this video to a close. I want to thank you guys. Let's continue the conversation in the description, in the comment section down below, as well as a link to the Ars Technica article in the description box. And join me over on Discord so we can have more great conversations. Consider joining the channel so we can play together and drink and have some fun. And as always, guys, I love it. Thank you.
And thank you.